So vehicle electrification implies a complete redesign of the vehicle. All the components have to be rethinked, and there are links between different parts for sure. You have to think about the impact of aerodynamics in the efficiency, cooling, the battery package, and the engine. You cannot think about isolated components the way you think in traditional vehicles. And managing temperature becomes critical. Batteries are only efficient on a very narrow operating range, and thermal management becomes a key topic. Let's say today, traditional OEMs have prioritized maybe hybrid engine, which kind of combine the challenges of the internal combustion engine and the electric motor. Indeed, somehow the engines are smaller, which implies they have to operate at higher RPMs, and thermal workflows become even more challenging. You have to be able to analyze the conditions at higher RPMs than even with the traditional internal combustion engine. And those that are taking the risk to go pure electric have to completely redesign the whole platform, the whole architecture, and somehow the challenges are different. You have to think about all the domains. You cannot approach the problem thinking about EMAG performance, structures, durability, NVH, and thermal fluid dynamics as separate topics, because all are closely interconnected. Electromagnetic losses will have an impact on the thermal performance of the engine, and you have to approach the problem in an holistic way. So that's basically what positions us in a unique situation to disrupt the design of electric vehicles, because we have all the components, all the technologies which allow to approach the problem in an holistic way, simultaneously optimizing everything for all the KPIs. Of course, on an internal combustion engine, the EMAG won't play a role, so you have that additional dimension, which of course increases the complexity. But the particularity of thermal management for electric engines is just maybe you have smaller components, smaller gaps. You have a higher rate of scales, so you have to account for a larger range of scales when you are analyzing an engine operating in the higher RPMs. Again, the higher the regime, the smaller the cascade of scales you have in the flow, and of course it increases the complexity of the problem, of addressing the problem by means of simulation to another level. Right, so Dassault Systèmes has the most complete portfolio of technologies covering all scales and all physics. So we are able to simulate from micro scale till macro scale till functional logical systems. So we are able to analyze not just the performance of an engine under nominal conditions, but also analyze cycles, even driving cycles. We can also play in the other dimension. We can tackle the optimization of the electromagnetic performance coupled simultaneously with structural durability and NVH and thermal optimization. So we are in a unique position to address the problem holistically, optimizing multi-KPI and considering all the domains that play a significant role in the problem.